Good morning, pilot teachers and students. Good morning, class.
Good morning, sir.
Okay, thank you very much. You may sit down. All right. In today's lesson, we will be looking at another force, and that is the magnetic force. Also, you'll find that magnetic force is a example of a field force. Very good. Okay, it is an example of a field force because it Amanda, why do we call it a field force? Okay.
Because it acts as a distance and doesn't come in contact with the object.
Okay, very good. A field force is a force that acts at a distance. Okay, because it does not come in contact. That is why we have to call it as a field force. Right, looking at a bar magnet, right, as long as if it is dipped into iron filings, most of the iron are attracted to the ends. Right, these ends are called the poles, and you find that if a magnet is freely hung away, it will always point in the same direction. Okay, that is for any magnets. Now, looking at the that is the Earth's magnetic field. You'll find that the north has to act as a north pole, and you have the south, which is acting like a south pole. Now, this is because of the mass of the Earth. That is why it has to create a field, and it seems to be having a north and also a south pole. On a magnet, you'll find that, that is a U magnet, you'll find that there is always a south pole and also a north. Now, the theory of magnetism, you'll find that in an unmagnetized piece of iron, the molecular magnets are pointing in all directions and so cancel each other out. For example, if you want to magnetize a piece of metal, if you decide to bring a magnet close to that and then you move it closer to the magnet, you will find that you will align the domains inside the magnet. And finally, after doing that, you will find that a piece of iron or metal will become a magnet, because the domains in there are being magnetized. Now, the next one, that is, for example, that is a piece of metal here, and you find that these domains or these magnet domains are not aligned, they are pointing in all directions or facing each other, and that is the reason why they have to cancel each other out. But if it decide to align the domains, you'll find that the domains will be always pointing in one direction, and you will eventually create what is known as a north and a south pole. The law of magnetism. Can somebody tell us the law of magnetism? Maima, what is the law of magnetism? Give him the...
The rule of magnetism are the opposite oppose or repel, and the like terms attract.
Okay, very good. So you have the unlike terms which like poles will have to repel, while the unlike poles will have to attract. I will go through this and then I will give you the notes to copy. Looking at this one, the like poles, and right here you have a magnet or two magnets. When you place the north pole and also the south pole, or rather the north and north, you'll find that this will repel against each other. Or if you decide to use the south pole and this, it will also repel against each other because you are using the like poles. In here you are using unlike poles. That is the reason why they have to attract, according to the law of magnets. All right, I will give you these notes to quickly copy. Right, you can start from these. Pilot teachers, please ask your students to co-train and have this theory of magnetism. I'll give you a few more notes and then I will, after those notes, right, there will be activities given. Okay, by now you should have finished. I will give you the next. Okay, just having a diagram. Those are the two magnets. The first one is where you have the unmagnetized region. Okay, in this case, the domains are unaligned, and that is for the first. Now, in a magnetized object, you'll find that the domains are aligned and facing in one direction, so you tend to have the north and also the south pole. Right now we will go on to the activity. All right, before that, okay, you can have the law of magnets, or magnetism. Okay. Pilot students, you can also take down the law of magnets or magnetism, and I will give you the activities later on. All right, moving on to the next. Here is a diagram to show that piece of information. All right, quickly sketch that. I will give you the activities. All right. I will give you the activities now, right, based on magnets. Pilot teaches this information on magnets can be further illustrated. If you have to use biomagnets, you can use it to demonstrate how you can align a magnet or how you can align a piece of metal. And you can use magnets to demonstrate. Right now I will give you the activities for this lesson. Right, the first one, as you can see, question number 1 is which is the North Pole, X or Y? you'll find that whenever a compass is placed beside a magnet, what will happen? Samuel. Where should the compass needle point? In what direction? Samuel? Right, good. Very good. It will have to point towards the north. So this information, using this information, you can do this activity. The first one has been done for you. Okay, that is A. Okay, which is the north pole, X or Y? You can plot this. Okay, just draw this one quickly. I'll give you the next piece of information. If you have your physics methods, there is a textbook that you can use. Turn to page 213. And you will find some information on magnets. Okay, there's some example given to you as well. Okay, finish that. I will give you the next information. Okay, for this one, you have to draw in the field lines, the shape of the magnetic field surrounding these magnets, and then mark any neutral points on the magnets. Which are the neutrals, neutral point, and which one of those, or which areas will have the strength of the magnetic field which is more greater. So after drawing the field lines on these two magnets, okay, so that with the indication of the direction of the field lines, okay. Okay, the very last question, that is question number. All right, just a statement here. You can go through two of the bar magnets have been placed inside a box. Use the information in the diagram to suggest how they are placed inside the box. Right, that information will be given in the next slide. So this is just information. Right, looking at this, you don't need to have this one. Okay, this information will help you to. Okay, you find that these magnets, two of the magnets are placed inside here. But and then you find the compass needle is facing in certain direction, which is placed outside the box. Okay, just draw in here how the magnets are placed by indicating the north and also the south pole. Okay, because of the compass needle there that are showing outside the box. Okay. Right, if I can. Now, this is a diagram that is showing you the information. Right, what you do is simply draw in magnets over here, and then probably you can indicate whether it is like this, north or south, or one is placed like that, having north and south. Okay, so that is what you are to do for the third question. Okay, that is question number 3. Diagram has been shown. Okay, two of the bar magnets have been placed or hidden inside a box. Use the information in the diagram to suggest how they are placed inside. All right, quickly discuss the questions. I'll give you a few minutes to complete question number 1 and 2 and 3. You finished question number 1? Okay, which okay, draw in the diagram which one of these. Okay, they are placed inside. So which one? If you have placed your compass here, which way should it be facing? Okay, like that. Okay, if you are going through,
Do these two, what do you call it, magnets studio lines meet somewhere, or is just separate ones?
they are separate ones, just draw in there. Yeah. Right, use the information on page 213 to complete those questions. Wait, let me see. You've done question number 1. Okay, where is number 1? You finish this too. Where do you indicate? Okay, we'll quickly go through the correction of the questions. Time is moving fast, so probably we'll have the first question. All right, but before we go to the first question, which is the North Pole, X or Y, we will look at how you can place the compass needle on those circles. Right, the first one has been done for you, that is A, and following that you will place the needle on B, C, and D. All right, I will ask the first person to come up quickly. So, okay, choose you do A, B. Okay, you will do B. C will be. Okay. Let me see. Kimberly, Sierra. Kimberly, you will do, and D will be. Waki, you come into D. Okay, you will be answering question D. All right, quickly come up so you draw that for B and then you indicate that. Okay. Question number 1. Let's have question number 1 and then move on to question number 2 quickly. Right, I am waiting for those people to come up quickly. All right, question 2. Who is supposed to question number 2? You want to help? Okay, Mama, you to B and you help him with C. All right, quickly come up. Okay, just indicate that on the, or if you want to, you can simply complete those. Okay, have a look at this. What do you think about B? Sulaiman? You think that the compass needle should be pointing in the direction? Yes or no? All right, it always points towards C? North. Now, in this case, you find that it is pointing in that direction. So for the first question, which is in North Pole, right, that is the North and that is the South. Why? Because this needle should always point towards the North. If you decide to bring it over here, you'll find that this one points that way. So that B will have to change and it will be pointing in that direction. This one will also point that way and that one should be pointing somewhere there because the field is coming from the north. Okay. Okay, so when you are drawing this, it is now pointing towards the north. And this one as, okay, that is South Pole, and the arrow should be also pointing towards the north. In here, the compass needle should be, okay, something like that. And that one should be. Right, moving on to question number 2. I'll quickly go through and then, right, that is how you can draw in the magnetic field lines. Simply, we have to draw that. Right, the first one was the north and south. So, okay, field line should be right, your diagram should look something like this. Not only these two field lines, but you can draw as many lines or field lines. For this one, the arrow should be pointing in a direction. Now, some of the neutral regions of the magnet, especially that is around here, where there is no field lines existing, okay, you will find that there is neutral regions. But in here, the field will be much more strong. And finally, okay, looking at two of the bar magnets and how they should be placed inside, or how are they placed inside a box. Okay, looking at this, all right, who can come and draw on that inside that box how the magnets are placed inside the Okay, look at the magnets. Tell us, is he correct? Yes or no? Yes. Okay, looking at this, that is how it was hidden inside a box. So the compass is pointing towards north. Okay, why? Because the field will be acting towards that way. So this one is pointing towards the north, while that is where it faces the field lines. Okay, because it is moving that way. And in here, you'll find that it is pointing towards the north, while this one is okay. Just have a look at this one. Okay, in this one, we will have, okay, that as the south, and that should be the north. Okay, so that is how the magnets are placed inside a box, right? Simply by looking at these 4 compass. Okay, very good. Now that brings us to the end of the lesson. Make sure you go through and then study more on magnets. As for pilot teachers and also pilot students, pilot teachers can also explain to you how you can use bar magnets to demonstrate how you can align the regions of a iron. Okay, simply we have to align those using a magnet. That piece of metal can simply become a magnet. So we have gone through looking at magnets in this lesson. For the next lesson, right, that is what you should provide for the next lesson. Right, we'll be looking at electrostatic force, polythene rods, paper rods, and also woolen cloth and pieces of papers. Right, using those equipments, we can demonstrate the electrostatic force. And finally, our keyword for today will be magnetic force. Okay, you can stand up now. Okay, with that, good afternoon, pilot teachers and students, and good afternoon, class. Thank you.